All right, so hey everyone. We'll be having a look at some differentiation and tangents to the curve to a curve. That's which is part of the maths methods curriculum for units 1 and 2. It's basic. It's just about building the foundations so that when you do methods units 3 and 4, right, then you'll have a good grasp, or at least have an idea of how to solve these sorts of maths problems. Let's have a look at what a derivative of a function is. The derivative is a gradient of the tangent line at a particular point on the curve. Let's say that I'm just going to get my graph up. Let's draw an illustration, for instance, right? Have y on this side and x on that side. And then, all right, so let's say that we have this original curve, which is a parabola, right? And then we have a tangent at this point here. So let's say that x equals 3, for instance. Let's just say that. And then that's going to be the tangent at x equals 3, right? This is the derivative of the curve. At this particular point. This is basically what a derivative is for the tangent line. It's a particular for the gradient of the tangent line at a particular point on the curve. So like for this one, for instance. And let's pick another point as well. Let's say that let's do x equals 1. We have x equals 1 here. And at this point, the gradient shifts. Right, so this isn't a very looking gradient, but that's all right. But as you can tell, the gradient changes quite dramatically. Well, in fact, it changes in magnitude because, as you can see for this one, it's a negative, right? Whereas for the other one, the x equals 3, right, it's a positive. At each point on the curve, right, and you can see that the gradient changes, or that the derivative of the gradient of the tangent line changes as you move along the curve. So that's pretty much what a derivative is. Let's get into the rule for it. So the rule for finding the derivative of the curve is as follows. If we have y equals x to the power of n, right, then the derivative of that is just going to be n times x to the power of n minus 1. So that's just the general rule. And another thing that you need to take note of is that for a constant term y equals a, the derivative for that is just going to be dy dx equals 0. So if it's just a constant term, then that's just going to equal to 0. If that makes sense. So let's have a look at some questions now. Let's have a look at the first one. So we have y equals 2x to the power of 2 plus 1. So we want to find the derivative of that. So we do dy dx equals, sorry about my messy handwriting, and it's not very good on here, so please forgive me for that. But let's find the derivative. Let's focus on this 2x squared term to start off with, right? To find the derivative of that, according to this rule, right, well, we have y equals x to the power of n. So in this case here, n equals to 2. So we have n equals 2, right? But for this constant term here, right, then it's just going to, the derivative for that is just going to equal to 0, since 1's just a constant by itself. Now let's find the derivative. So we have 2 times, so we have n on this side now. So we have 2x, and then 2 minus 1 is the power, since dy dx equals n times x to the power of n minus 1. And then finding our answer, we just have 4xn. So this one is fairly simple. We just, yeah. So hopefully that should make sense. Next one, so we have y equals 3x to the power of 3 plus 4x to the 2 plus 6. So for this one, right, we have the power of 3 and the power of 2 for this one. So let's focus on this power of 3 for first. So we have dy dx equals 3 times, so we bring this 3 next to the x now. So we have 3 times 3x. And then we just subtract 1 from this power of 3 here. So it becomes 3x squared, and then we multiply by this 3. And then adding that, we have 4 times 2x. And then because 6 is a constant term, again, we just, that becomes a 0 then. So now let's evaluate this. So we have 9x squared plus 8x. So again, this shouldn't be too difficult, but just focus on each of the terms. Just find the derivatives of each of the terms first, and then you can add the rest of them up. So hopefully that should make sense. So next one, y equals 8x to the 4 plus 6x to the 3 plus 2. So to find that one, we have 8, and we need to multiply 8 by bringing this 4 down to the there. So we have 8 times 4x, and then subtract 4 by 1, so 4 minus 1, according to this rule again. So we have 8 times 4x to the 3, and then plus that by 18x to the 2. And then we just have 32x cubed plus 18x squared. Let me just fix this 18 now, just in case you can't see it clearly. Oh yeah, so this looks much better now. So you should be able to read this more clearly. All right, so next one. So next one is a little bit different because we have this what 4 divided by x, with x being the denominator, and then we subtract that by 4x. So so the way we deal with this sorts of questions is that we get rid of the fraction sign. So we just have dy dx equals 4, and then x to the power of -1, right? And then subtract that by 4x. And then just bring this power of -1 to this side, so we just have -4x to -2. And then we just have -4 there. Then we can put it back into a fraction again. So we have dy dx equals to -4 over x squared minus 4. Or another way we could have a look at this is that we could do it this way. So we have dy dx equals -4 x squared minus 4. Well, I'll just show it in a more general way though. So let's say that well, let's do it. Let's do it in a different color. So let's do it in red. So let's say that we have y equals a over x, right? And we want to find the derivative of that one. So the shorter method that we could use is that we have dy dx equals negative a over x squared. So that's just another way that you could do it. But personally, for me, I prefer the longer method since I find it easier to work with. But whatever way works for you is fine. So it's just that personally, for me, I prefer to do it this way. So that you might have your own preferences. All right. So let's have a look at question 5 now. So let's have a look at that one. Okay, so for question 5, right, because we have the power of 2 as a x to the power of 2 as a denominator, right, and I prefer to do it with the longer method since it's easy to work with. So for this one, then we have the way to do this one again is that we cancel out the fraction and then we just have 2 x to the power of negative 2 then. Right, so and then we have dy dx equals negative 4x and negative to the power of negative 3, and that's just going to equal to minus 4 over x to the 3. So hopefully this should make sense. This shouldn't be too difficult. All you have to do is just cancel out the fraction sign and then bring the x variable to where to the coefficient to. So and then you can just have the power as a negative sign then. So and that way you can find the derivative from there, and then you can go back as with a fraction sign so that we can have our x variable with a positive power then instead of a negative power. So so that's how I like to do it. So nice. So this is just yeah, basically how to find the derivative of the following. So it's not too hard to do. You just need to follow this rule, and once you're able to implement this rule, then you can find the derivative easily enough. So so that hopefully you should be able to understand this. So let's have a look at finding the gradients of tangent lines at specific points. So let's have a look at the first question. So find the gradients of the tangent line to the curve y equals 3 x to the power of 3 plus 2 at the point 26. So before we find the gradient, right, what we need to do is we need to find the derivative. So we have dy dx equals 9 x squared. So that is our derivative here. So and let's also illustrate, and let's also yeah, illustrate on the graph. So the tangent line. So let's say that we have y. And then we have our point of inflection at x equals 2. So this is our cubic function. So this is at 0, 2. And then let's say that x equals 2 is, I'll do it in a different color. So let's say x equals 2 is around here somewhere. So so the gradient of this line, so the tangent line is going to pass through x equals 2 and then it'll just look like a gradient, a straight line going through this particular point, x equals 2. So this is the tangent line, the red line. So now let's find the gradient of the tangent line. So the way we go about that is that we substitute x equals 2 into the derivative function, so that we have dy dx equals 9 times 2 squared, and we just get 36. So that's our gradient of the tangent line. So it's 36. So don't worry. Also, don't worry about the point where y equals to 26. That's just for the cubic function, though. So try not to get confused about this point and where y equals 26 and x equals 2. So just focus on the x equals 2 part and subbing that into the derivative function. That way you just get the gradient of the tangent line. So yeah, so that's all you need to do. Don't worry about this y equals 26. All right. Next question. Find the gradient of the tangent line to the curve in y equals x squared plus 2x plus 1 at the point 1, 4. So first of all, we need to find the derivative before we find the gradient of the tangent line. So our derivative for the function is just going to be 2x plus 2. So and then subbing x equals 1 in, so we get x equals 1 radians equals 2 times 1, and it's just going to equal plus 2. And it's just going to equal to 4 then. So and I'll show you what it looks like on the graph as well. So let's say that we have y there and x there, and then we have our original graph, right? So that's just our original curve, where the turning point is going to be -1, 0. So that's our turning point, and then at x equals 1, so that's x equals 1 here. So this is just our gradient of the tangent of the tangent line at x equals 1. So hopefully this should make more sense. So and hopefully you've learned something from this lesson as well. So let's just briefly recap on how to find the gradient of the tangent line of to the curve at a particular point, right? So what you need to do first is you need to find the derivative dy dx of the curve function, and then from there you just need to substitute the x value of the points into the derivative function, and then you get the gradient of the tangent line. So that's just how you go about it. And to find the derivative of a function, right? You need to if we have y equals x to the power of n, right? Then to find the derivative of that, then you just bring this power of n over to this side, right? So it becomes n times xn, and then x is just going to be n to the power, and then x just has a power of n to minus 1. So therefore, the derivative function is just going to be n times x to the power of -1, as shown here. All right, so hopefully you'll be able to implement that rule when you do find derivatives of curves and whatnot. So, and just one final thing to recap on is that for a constant term y equals a, and the derivative of that is just going to equal to 0. It's the same with any number that doesn't have a variable like x or y next to it, and it's just always going to equal to 0. So yeah, thanks for tuning into this video, and I will stop there.